Let us learn about linked hash map. We have already learned about hash map. I have explained it in previous video. Hash map is used for storing key and values. So map entry will contain key and the value. So similarly, linked hash map is also used for storing keys and the values. But linked hash map is little different from hash map. So I will explain linked hash map in comparison with hash map. A hash map will contain hash table. This is hash table. But in hash map, only values will be there in the table. But in linked hash map, there are two pointers like doubly linked list. So next and previous pointers will also be there. So it will be having a doubly linked list along with each entry. These places are called as entries, or these places are called as buckets. For each bucket, there will be a pointer like doubly linked list, like next or previous pointers. So hash map is an array of buckets where it will have only values. Linked hash map will also have linked list along with each bucket. Next point. The elements are inserted, or keys and value pair is inserted in this table or in this hash table by using hash function. In hash map as well as linked hash map. In both it happens in the same way. The next point. For the better performance, we prefer that the hash map should not be filled more than 50%. Similarly, for the linked hash map also, we prefer that half of the bucket should be used, half of the bucket should be left empty. So why only 50%? Because if there is a collision, if more than one keys are mapped on the same location, then the next location is used for storing the element. So if you try to occupy all the places, then it will be difficult for looking up or searching for any value inside the hash table. But when you create an object of hash map or linked hash map, by default it takes 75% of loading factor. So ideal is 50%, but if you take 75% also, it's okay. But make sure it is not 100%. Never use 100% of hash table. The performance will reduce. So these are all common things. Hash table is common, hash function is common, loading factor is common, and the key values are inserted. Now let us see the difference. I will show you the difference while inserting the values. Let us insert the value 12. 12 is for 12 mod 10 is 2. So at this place 12 and A is stored. Then 17. Let us take 17. 17 mod 10 is 7. So at this place 17 and A is stored. In hash map, only the key and the values are inserted like this, entries are inserted like this. But what about linked hash map? Now watch it carefully. This is next and this is previous, right? So I have taken this as next. So next key for this one is this one, and previous for this one is this one. So this means this is the first one. This is the first one. So what is the use of this? This is maintaining the order in which keys are inserted. See, the first key inserted is 12, then the next key inserted is 17. So it is pointing, next is pointing here, and its previous is this one, 12. So yes, this linked list is useful for maintaining the order in which the keys are inserted. That's what the linked hash map, this is how it is different from hash map. So linked hash map maintains the order by maintaining a linked list for each bucket. Let us insert few more values. Let us insert 14. 14 mod 10 is 4. So 14 is inserted here. 14 and C. Then after 17, this is next. This is next, right? So this 14 is next. And for 14, this is previous. 17 is previous. And 14's next is not there, so this will be null. Likewise, 12's next is not there, so this will be null. So if you start, first you will get a key 12, then it gives the next address of 17, then it gives the next address of 14. So like this, you can traverse or iterate through these keys in the order in which they are inserted. So I don't want to add more keys. It will look more complex here, complicated here. So with these keys, you understand how the linking is done. You can understand it more clearly if you have the good idea of doubly linked list, because I am not explaining doubly linked list here. Now next, instead of 25, I will make it as 24. Let us insert 24 and show you what happens now. 24 mod 10 is 4. So it will go here only, but this place is occupied. So 24 is stored here, 24D, it is stored here. So that when you look up for the next time for searching, we will use 24 and come here 4, but 24 is not found here. Then we will look at next free space. Yes, the value is found. If next free space, next space if you look at, and if it is empty, then we say key is not found. Let us say I want to search for 34. How searching is done? Let us check. 34 mod 10, go here. Is it 34? No. Go to next. Is it 34? No. Go to next. It's empty. So 34 is not there. So this entry is null. So 34 is not there. So that is the reason we want some empty entries, so that we can say that element is not there, element is not found. That's why we want the less percentage of filling of this hash table. It should not be 100%. It should be less than 100%. So that's all. I have explained you the working of hash map as well as linked hash map. All right. Now let us talk about linked hash map. Linked hash map will maintain the order of keys in which they are inserted, the order in which they are inserted. Hash map will not do that. That's the first point. And the second point is, if you limit the size of linked hash map, if you say that it should not be more than 10, suppose if you limit the size, then after inserting 10 keys, if you insert 11th key, then it will remove one of the key. So which key it will remove? It will remove the first key. All right. So you can limit the size, and if you insert more keys, then it will not stop you from inserting more keys, but it will delete the existing keys. So it will delete the first inserted key. Then if you insert again the next inserted key, so the keys will be deleted in the order in which they are inserted. Then next, see, this order was based on insertion. Okay. Then there is one more possibility. In the linked hash map, you can maintain the order of the keys in order of their access. If you have accessed the keys, then those keys are shown first, and the least access keys are shown at the last. And if you change this order to access order, at that time, if the limit is 10, and when you are inserting 11th key, then the least access key or least recently used key will be deleted. So the least recently used key or least recently accessed key value will be deleted. See, what is the use of this? So this type of behavior or functionality is commonly found in cache memory. So if you want to implement cache memory or cache memory, then you can use linked hash map, which will work like a cache of object for you. You can keep the keys or key values inside the linked hash map, and you can maintain this order, access order. So this will work like LRU. So you can insert or delete the objects based on LRU fashion. So least recently used objects can be removed. The objects which are not in use can be removed if you are having a limited capacity. So these are the benefits of using linked hash map. So it's little better than hash map. Now what about the performance? See, the operations like put for inserting a key or get for getting a key, remove for removing a key, they all take constant time, because we are reaching a particular key by using hash function, right? So the time taken by hash function is constant. So within constant time, we can reach at any place. So all these operations are performed in constant time in both in hash map as well as linked hash map. But in linked hash map, iterating through all the keys, means visiting all the keys and the values, will take more time, because it has to use this linked list, doubly linked list, and access all these elements in the same order of linked list. So that is the reason iteration is a little costly process in linked hash map. So that's all about hash map and linked hash map. We will look at the demonstration for this linked hash map in the next video. I will show you how it is used as a cache memory.